Hello, my name is Atanieli Magashi, and I'm presenting today our experiment on how density affects wavelength speed. In this experiment, we tested different materials to see how they reacted to disturbances through watching the waves created in the material. We used water, oil, and soap to conduct our experiment.
The law we are referencing today is the shallow wave theorem, which states that shallow water surface waves interact with the bottom of the tank and slow down as a function of the square root of the depth of the tank. This theorem applies in this case because the depth of the samples we used were very shallow, only 2 centimeters. In this case, we predict that density will not affect the results of the speed.
The waves we observed were mechanical waves because they involve motion. For mechanical waves, the wave must transfer through a medium, but the medium does not travel. There is no transfer of any material outward from the point of disturbance, only energy. We use the speed equation to measure the speed of the waves. Along with this, we use the density equation to figure out the density of the liquids that we use. Finally, we use the shallow wave speed equation to find out what our expected values would be.
Here is the wave speed equation in shallow liquids. It states that wave speed will be the square root of gravity multiplied by the depth of the liquid. Clay ball into the center of our tank. We filled this tank up with half a gallon of liquid, in this case water. We dropped the ball into the water and watched for the first wave it created to reach the edge of the container. Every move this wave made, we created a point in the video analysis app. This yielded this graph. The slope of this graph is the wave speed. In the case of water, the slope was 0.1906 meters per second.
For the oil, we dropped the air-dry clay ball at the same height as the water sample. We used a similar procedure for the water analysis to plot a point whenever a wave moved. The slope for this plot was 0.2394 meters per second. This is the wave speed of the oil sample.
For the soap, we dropped it on a higher height, as when we dropped it from the same height as the oil and the water, there were no visible waves. From a higher height, we were able to identify 2 waves. These waves, though, did not extend all the way to the end, making it difficult to identify the wave speed. From the 2 points we were able to plot, we found that the wave speed was 1.061 meters per second.
So we predicted that all the liquids would have the same wave speed of 0.14007 meters per second. Our observed wave speed for water had a 36.06% error. The observed wave speed for oil had an error of 79.99%. And finally, the detergent had a very large error of 678.90%. While water was relatively close to the expected value, the other liquids were not. A cause of the error among the liquids may come down to their viscosity. Water, oil, and detergent all share different viscosities. It is possible that the shallow wave theory equation does not account for the effects of viscosities in liquids.
From me and Celeste, thank you for watching our video!